Okay, students, welcome to the review for the parallel line angles quiz. Some of your headers at the top of your first page, I forgot to change it before I saved it out, and you'll have the older one, but this is going to be on parallel line angles. I want to review first how we write angles. Angles can be written as a capital letter, an angle symbol with a capital letter. They sometimes are written with an angle symbol and a number, just a number. And sometimes they're written with an angle symbol and 3 capital letters. That's the kind that I want to talk about here. If you look at this drawing, I've labeled all the angles, but we're just going to talk about one really quick. I'm going to talk about this one right here. If I look at this one right here, it comes down like this, and then it comes over like this. If you look, the letter Q is in one of the arms, the letter S is in one of the arms, and then the vertex, where the 2 rays or 2 arms meet, is at the letter R. An important thing here is that the letter R, when you use 3 letters, the middle letter has to be the vertex. And so that's why we've done, notice that we've switched the letters on the outside, and that's okay, but the middle letter has to be the vertex. Sometimes you can also think about reading it from right to left. You start at point Q, go through R, and then up to S. Well, that has to be that angle right there. Go ahead and look at some of the other ones when you have time. We're going to go on and look at adjacent angles. Adjacent angles are 2 angles that are right next to each other that share a common ray between them, but they don't overlap. Here's the example where they overlap, and that's not a, we don't consider those adjacent angles. The important thing for us about adjacent angles is that adjacent angles add up to the whole angle. This is really, really important. If you look here, if I took this ray in the middle out and didn't have angles 1 and 2, I just had this bigger angle, it would be 120 degrees. Well, these smaller angles have to add up to that 120 because there's nothing left between there. There's no open space, like maybe like if you look at this one, you've got that and you've got that, but you don't have this. So those two don't add up to the big angle. We're going to look at that in a moment, and that's going to be really, really important. So if you need to, stop and think about that for a moment, what we're saying, that we say that angles can be added if they're adjacent. Okay, the other idea I want to make sure I get done really well is what vertical angles are. Okay, anytime 2 lines cross, 2 sets of vertical angles are formed. They're the angles across the vertex. So here's the vertex. So there's one angle here that's vertical to this one, and those 2 angles are going to be the same. They're going to be different than this one right here, but this one is going to be the same as the one across the vertex from it. Same means equal. So if this one was 40, then this one's going to be 40. If this one's 50, then this one's going to be 50. Kind of remember that, because those are the two of the big 3 ideas that we're going to see in the work we're going to do on this little first video and this first section of the review packet. Now, let's look at this. This is a straight line. Anytime you have a straight line or opposite rays going, or 2 rays going in exactly opposite directions, the angle they form is 180. Think of looking at a protractor. Here's a protractor that I can kind of move around. You can see that that straight line is basically 0 and 180 because it's basically 180 degrees if you go all the way. Now, what happens here? Let's think of that adjacent angles adding up. These 2 are adjacent angles. Okay? So take a moment to think about why this is so, and I'm going to tell you to pause and then start the video once you've kind of had some time to think about this and write some stuff. Okay, let's go ahead and go on. Basically, here's my big angle. That big angle is 180 degrees. So these 2 have to add up to 180. This is the way we usually will say it in geometry class over and over again. The sum of the parts equals the whole. I better spell it out. equals the whole. In other words, the whole angle here. Okay, now let's look at this one. It actually follows the same thing, except I have three angles. These three angles have to add up to the whole angle, which is 180. So we have the same reason here as we did up above. Now we're going to look at why this one, if I only mark these two angles, why don't they add up to 180? The reason is that without this angle as part of it, I really don't have the whole angle. I have something kind of like this, then this, but that's not the whole angle. I need this. Now, if I were to give you these two angles, like let's say this one is 80, and let's say this one is 40, that's 120. So 180 minus 120 would have to be, was that 60? So this one has to be 60, but these two by themselves don't add up to 180. Okay, so let's look at these supplementary angles. If two supplementary angles are adjacent, not supplementary, if two angles are adjacent and they have a straight angle on the outside, they're going to be called a linear pair. These are not a linear pair because they do add up to 180, but they're not adjacent and they don't have a straight angle on the outside. These add up to 180, but they're not adjacent. Now, you'll see this pattern a lot, and remember that the two angles will add up to 180. All supplementary angles add up to 180, but these especially. So now let's look at an example. I'm going to do this first one up here, and you're going to be doing the other two in this video, and I'm not going to give you the answers to those. But first, let's look. The easiest one to do is a vertical angle. This angle right here is vertical to that one, so this one has to be 70 degrees. So I'm going to say this is 70 degrees. I don't need to calculate it. And why it is vertical, I'm just going to say vert to the angle that is 70 degrees. I didn't give it a number, so I'm just going to call it that. Now, these angles over here, this angle, if you go from here all the way over to here, just think about that. It has to add up to 180, but angle 1 is not 180. This whole angle. If this is 70, that uses up 70 of the 180. How much is left? Well, the amount that is left is this angle, and so it's 180 minus 70, which is 110. That's the way you calculate angles when they're supplementary. So it's 110, and my calculation was 180 minus 70. It's 110. And the reason why is it is supplementary to angle 2. It's also a linear pair with angle 2. Okay, what about angle 3? Angle 3 is supplementary to angle 2, so I could do the same process again, but it's easier just to say it's vertical to angle 1. So that's the reason I'm going to use, because I only need one reason on this one. It's vertical to angle 1. Okay, you've got the remainder of these to do, and the next video we'll start talking about corresponding angles.